Lewis structures are a way to represent bonds and show how the valence electrons are arranged in those bonds, based on the idea that all elements want to get to 8 valence electrons, which is the same as the noble gas configuration. So all of our elements will bond to try to get our 8 valence electrons. So remember the rules on valence electrons. So if we look at our periodic table, we can know the number of valence electrons based on the group. So group 1 has 1 valence electron, group 2, 2 valence electrons. Then we don't worry about the transition metals. Then we jump over to group 13, 3 valence, 4, 5, 6, until we get to our noble gases, which have 8. So don't forget that. We're also going to need to remember our different types of bonds. So remember that an ionic bond is between a metal and a nonmetal. We have a transfer of electrons, which means we're dealing with ions. So we're going to have a plus, our cation, and our negative, our anion, and that's what causes them to stick together and form that bond. A covalent bond is between a nonmetal and a nonmetal. So we're looking at compounds from the right side of the periodic table bonding together, and they share electrons. And because they share electrons, they can be solid, liquids, or gases at room temperature, where ionic bonds are always going to be solids that have a crystalline structure. Metallic bonds are between the same metal, and they also share electrons. But this is in a sea of electrons, where the electrons start to drift away from the atom, but they're still held there by the opposite charge. They also form crystalline structures with this sea of electrons. So if we're looking at bonds, here are our steps for our Lewis structure. First, we're going to obtain the sum of valence electrons for all the atoms. So we're going to use the periodic table in order to figure out how many valence electrons we've got in this bond. Now we're going to use one pair of electrons to form a bond between each pair of atoms after we find the central atom. So this is all going to be around the central atom. And the central atom is our element or atom that has the fewest number. So in H2O, it's going to be the oxygen. Then we're going to rearrange the electrons to follow the octet rule, and we're going to start at the outside. So we're going to look at our outside elements before we go in and deal with our central atom. So our first step is to find the valence electrons. So if I look at my periodic table, hydrogen is in group 1, but we've got 2 hydrogen here, so 2 there. We've got 6 from our oxygen, so we have 8 total valence electrons. Next step is to find our central atom. So I have more hydrogen than I do oxygen, so oxygen is going to be my central atom. So I'm going to start with him, and then I'm going to do bonds. Then I'm going to do bonds to each one of my hydrogen. And hydrogen has one valence, and he's happy when he's got two. So he's got one here from himself and one from the oxygen. So he's happy, so he's filled. So we've got 4 of our valence electrons of our total 8. So now let's go and put the rest around oxygen. So 1, 2, 3, 4 coming from the bonds, 5, 6, 7, 8. Let's check and make sure everybody's happy. So hydrogen's got one here and one here. He's happy with his 2. We've got hydrogen happy over here with 1 and 2. Then we've got our oxygen, 1, 2, 3, 4, 5, 6, 7, and 8. He's filled his octet rule, and we've used all 8 valence electrons here. So that is the Lewis structure for water. So again, start with your valence electrons. So nitrogen is in group 5, or 15, so he's going to have 5 valence electrons. Hydrogen each has 1, and we've got 3 hydrogen here, so we've got so we've got 8 valence electrons. So we've got our central atom is going to be nitrogen because we've got 3 hydrogen. So nitrogen, and then bonds for each of the hydrogen. Again, hydrogen is going to be happy at 2. So we've got his 2. So 1 and 2 for this hydrogen, he's sharing with his nitrogen. 1 and 2 for this hydrogen, 1 and 2 for this hydrogen. So all of our hydrogen are happy, so we are not going to draw any lone pairs out there for him. But nitrogen is not happy because he's only got 1, 2, 3, 4, 5, and 6, and we have not used all 8 of our valence electrons that we've got here. So we're going to need to draw in those lone pairs up at nitrogen. And now this is finished. Again, first step, use your periodic table, find the valence electrons. Carbon has 4. Hydrogen each has 7, so 7 times 4. We've got 28. 28 plus 4 gives us a total of 32 valence electrons. So I've got less carbon, means that he's the central atom, so start with your carbon. Then we're going to do bonds for each of our fluorine, so 1, 2, 3, and 4. Fluorine is not hydrogen, so he's going to follow the octet rule, so he wants 8. He's got 2 in his bond with carbon, so next we're going to start to fill him up. So fluorine, we're going to start drawing in lone pairs. 1, 2, 3, 4, 5, and 6. He's got the 2 that he's sharing with carbon, so he's now full. And we're at 2, 4, 2 here in the bond, 4 here total in the bond, 6, 8, 10, 12, 14 out of our 32. So we've still got some electrons. So let's fill up our next fluorine. Now we're at 20 valence. We've got to get to 32. So next fluorine, fill his octet. 6 in his lone pairs, 2 in his bond. So now let's count up our total number of electrons and see if we've gotten to 32. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 8, 30, and 32, we have met the valence electrons that are in this bond. Let's do one more, and this time we're dealing with an ion. So we've got sulfur, who has 6, Oxygen has 6, but then we've got these 2 extra electrons. So we've got 30 coming from our atoms plus the 32, so we've got 32 valence electrons. Let's start with our central atom, which is going to be sulfur, bond to oxygen, bond to our other oxygen, bond to the next oxygen. Now we've got 4 oxygen. That's 2, 4, 6, 8. And our sulfur is happy because he's sharing 8. So the rest of the electrons are going to go on the outside. So 8, 10, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. The only thing that we have to do extra is we're going to show that this is an ion with a -2 charge with our parentheses around it. There's sometimes that it doesn't work out just with having one bond in between to fill our octet rule. So a double and triple bond will be represented with either 2 lines between atoms or 3 lines, depending on if it's a double or triple bond. So here they're going to share more than 1 pair of electrons again to try to fill that octet rule. A double bond will involve 4 electrons and a triple bond will involve 6 electrons because each line represents 2 electrons. Each time we add another bond, we increase the strength of the bond. So let's try oxygen. So oxygen has 6, so we've got 12 valence electrons here. So oxygen bonded to our oxygen, and let's fill our lone pairs. So 2, 3, 4, 5, 6, 7, 8. That oxygen's happy. 9, 10, 11, 12. I've met my valence electrons, but look, this oxygen is not happy. He has not met his octet rule. He's only got 2, 4, 6 electrons. He's not happy in this bond. So what we're going to have to do is we're going to have to move 2 electrons from this oxygen, and they're going to have to share. So we're going to do that by creating that double bond. So these guys are going to come over here in that bond. So this is what it's going to look like. So we're going to have a double bond between our oxygen. 1, 2, 3, 4. 2, 3, 4. So each are now happy because they've got 2, 4, 6, 8 that they're sharing. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have our valence electrons all accounted for. Last thing with these bonds is called resonance, which occurs when more than one Lewis structure can be drawn for a molecule. So we've got nitrogen and oxygen together. Nitrogen has 5 valence electrons. Oxygen has 6. This is an ion, so we're going to add 1 more. So we've got 24 valence electrons here. So let's try drawing this Lewis. Nitrogen's going to be in the center with oxygen bonded to it. So there's 6 of our valence, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. But, okay, so all of our oxygen are happy now. But nitrogen is not because he's only got 6. So that's not going to work. So let's try sliding some of those electrons up into a double bond. So nitrogen is their central atom. Do a double bond to this oxygen, bond to each one of our other oxygens. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. It's an ion, so we're going to put the parentheses, -1. But resonance means that we can draw more than one. So this double bond can be here or here, so we can draw it multiple ways. And then draw your lone pairs. So it's the same Lewis structure, just this time we're moving the double bond and you can move it over here as well. So that's resonance. I hope this video helped.